Hi guys, in this video I'm going to talk about type of activation function. Basically there are four type of activation function. First is Heaviside function. This function is also known as step function. In this function f of I is equals to 1 if I is greater than 0 and 0 if I is less than or equals to 0. We have input sum of all the inputs, that is suppose w1 into x1 plus w2 x2 and so on, and if this sum is 0.9 then we can say it will be 1, and if it is less than 0 then our output will be 0, and the graph for this will be as a step function. Second function is the identity function. The linear neuron or linear network is called as identity function. As the name suggests, identity function, we will have f of I equals to I. That is, suppose our I value is 0.9, then f of 0.9 will be 0.9. And graph for this identity function is y is equals to x. Coming to the third function, that is sigmoidal function. This function is continuous function that varies gradually between the asymptotic value 0 and 1 or minus 1 plus 1. F of I is equals to 1 upon 1 plus e raised to power alpha I. This function value is from 0 to 1, that is we have two asymptotic nodes and our graph will be between this asymptotic value, where alpha is the slope parameter which adjusts the abruptness of the function as it changes between the asymptotic value. Suppose we have this alpha value as 1, then we will have one graph with particular slope, and we have alpha value 2, then we are going to have different slope of the function. Fourth function is sigma function. It is also known as quantizer function. F of I is equals to plus 1 if I is greater than 0 and 0 if I is less than equal to 0. Here we have some theta value, that is this theta is threshold value. We will have our graph change the value when this, suppose this value theta is 0.5, so our graph will change on 0.5 and so on. So for the value in which this theta I is less than theta, we will have this graph, and when theta I is greater than theta, then we will have this part of the graph. This was all the type of activation function. Thank you.